Okay, so yes, as we wrap it up on alcohols, we've done everything. I mean, I just need you to remember. I know you will all remember hydration. I know you all remember hydration, adding water and sulfuric acid. It's not a problem. I know you all remember reduction, where you do the reduction of this aldehyde, of this ketone, of this carboxylic acid, and of the ester. You will remember all that. I know you can do that. Where the ester, you know that we cut it here. The carboxylic acid, you know what happens. You know how this becomes an OH and thus this becomes an H, okay? So we know all that. We've talked about all that. Okay, how this becomes an OH and how this becomes an OH. We've talked about all that reduction, and how here we use the stronger one, which is lithium tetrahydroaluminate, Now, anyway, now what I need you to focus is on the last part of the production of alcohols, okay? Remember how you come from halogenoalkanes or alkyl halides, where you have an alkane and a halogen stuck to it. Remember to add sodium hydroxide and water to make your alcohol, okay? And remember that why? Because sodium brings heme sodium loves group 7 things. So it's going to pull the bromine to itself. Remember that. Do not forget that, and it becomes your NABR. And then the OH will just go and attach itself on the missing thing. No problem. And also remember what happens for halogenoarenes. Don't forget halogenoarenes. We still add the same thing, but then it's a two-step process because we're going to add HCl on the next step. Okay, remember that we should do it at 300 atmospheres and 623 kelvins. This one. Remember that the two reactions with conditions is this one and dehydration. Dehydration, we do it at 180 degrees Celsius or 453 kelvins. Okay, this is 623 kelvins and we add NaOH. And it's going to give us an alkoxide where we add our HCl and we'll get our alcohol. Now the last one is aniline. Aniline to your alcohol. We are producing alcohols. Aniline, what is it? It is when you have an amine stuck to your benzene ring. What should you do? Add sodium nitrate and HCl first, to the two of them together, and what happens is N gives the N here and H gives the Cl there, so we'll end up having two N's and a Cl, but the two N's give you a plus and the Cl gives you a minus. Then this H2 will go, it will come down. So that's what happens. Then we have this water being added on the next step, and you heat it up a bit, and then you end up having your OH. Do not forget that. Do not forget that. I'm counting on you. Don't forget these last ones. Practice them. The last ones on preparation. As well as here on the alcohol reactions. I know you will remember dehydration. I know that. You will remember it. Where you just add the same thing as you added in hydration, but now you heat it up. Okay? And there's no water there. The water is already there inside the alcohol. So anyway, you heat it up and then we know it's going to go and become your alkene. And you should remember that in here, in the hydration, we use Markovnikov, okay? Markovnikov's rule, okay? We use the rule of Markovnikov, which says that the major product is formed when hydrogen goes to where there are more hydrogens. On the two carbons you have here, right? One will get an H, the other one get an OH. We know that H will go where there are more H's, and then OH will go where there are less H's. To the carbon that has less hydrogens. That's Markovnikov's rule, right? Remember that there is on hydration, and they can ask you on dehydration again, to a reaction mechanism. So you should know that. You look at the videos on mechanisms. Now here on the video on mechanisms, here we come to dehydration. Now on dehydration, we don't use Markovnikov, no. Now you must know, of course, about other things that we do here, like a special thing when you have like something like you want to add HBr. Remember that we add water like this here in hydration, or we can add HBr. And again, the same thing happens. Hydrogen will go to the carbon with more hydrogens in this double bond. But you can add a peroxide, something like this, or like this, okay? And this will cause you to do anti-Markovnikov. That's not for this. You can go and check on hydration of alkenes. We talk more about it when we are doing alkenes. Now here for dehydration, we deal with what we call Zaitsev's rule, okay? Zaitsev's rule, which is, you want to know, okay, I know that OH is going to go from here, but for me to make my double bond, is it going to be the double bond here or the double bond here? Who goes? It's easy if the double bond was on the last carbon, but here it's not on the last carbon. So we want to know who goes. Now, this OH is bonded to this carbon, so of course it's going to go. Then who else? The carbon from where? Okay, let's make this a hydrogen, make it more interesting. We say to make it just interesting, I mean, is this hydrogen going or this one? Well, what happens is we take H from the carbon that has more carbons to it and less hydrogens. It's actually weird. When we are taking the hydrogen, we take from the carbon with less hydrogens, okay? So this carbon here, you can see it has 2 hydrogens. This other one has 3. So we take a hydrogen from this one with 2 and this OH. So the double bond will be like this. Let's say it's true. Anyway, that is it for the thing. Then after you do dehydration, where you should know the conditions, you should easily know them. Where you must really make sure you don't forget is the halogenation. There is a whole lot that we talked about. You can go to the video on it, but you should know these 3 guys, SOC and this generally they write this guy as PX3, where X represents any halogen, okay, whether it's chlorine, bromine, or whatever, iodine, you can have it. So here usually the ones that you see is chlorine and bromine, okay, PCO3 and whatever, and you should know how they react, who they react with. We'd say that this guy, you will never see him. This first one, you never, their job is just to bring the bromine or the chlorine, remove the OH and bring the bromine or the chlorine. So when you react this, it's very easy. Just remove the OH, put the bromine or chlorine, but then you must know what you then get as the other products as well. So that is why we work so hard on all this. That is what we were trying to do. And, you know, hard work never killed a man. It's beautiful. Work is beautiful. It's amazing. So in here, well, whatever you get. And here, so here you have the your alcohol meeting HBr, and we said tertiary alcohols are usually the ones that love this guy. They're the ones that work with this guy. Then these 2 only work for primary and secondary, and they work for cyclic alcohols as well. So now we've seen, but we said this one, we like it, yes, for primary and secondary, but for those with high boiling point and melting points, we love SOCO. Now we keep going. I love this. I'm enjoying every step of this. This is beautiful. So yes, SOCO2, we talked about it. This PBr3, we said it also works for cyclo and for pheno as well. It works, but we usually like to use it for things with a lower melting point and boiling point, right? Okay. Now esterification, we have this. Esterification as well, a very easy reaction. After halogenation, we come to esterification. Then we come to oxidation. This is all easy stuff. Nothing is hard there. Then after this, we saw the reactions of alcohols with, number 1, if you have these straight chain alcohols, they can meet metal or metal hydride. But these phenols, either it's a metal or it's going to be a metal hydroxide. And we see this reaction of an alcohol with a metal. Here we see this reaction in Williamson synthesis when we are making ethers, because here we should know that here we always make an alkoxide. Anytime we are doing all these, you can see that we are always making an alkoxide. This is now called a phenoxide, okay? This is called a phenoxide, and yes, we have another phenoxide here, okay? And we either add a metal or metal hydroxide, not a metal hydride for this guy. Now, on combustion, we have it. We have the alcohol meeting oxygen itself, not an oxidizing agent. We talked about it. And breathalyzer test is the last one, where we say that this is the last round before we talk about something very interesting called ethers. But here we have the breathalyzer test, where we had our dichromate, whatever ion, and an acid meeting your alcohol, your ethanol, specifically ethanol, because it's the one that you find in the alcohol. You want to test if you're drunk or not. So if we meet it, then it's going to change this guy to just the chromium 3 plus ion, and in the process it is then changed, the ethanol, it is changed to ethanoic acid, and we have water. So this is what we have, and this is interesting on alcohols. You remember, keep doing it again and again and again and again. I beg you to remember especially these last 3 on the preparation reactions. I don't know how many times I've said it, 100 billion times. They are easy to forget. So keep doing them, master them, and be the best at them. Okay, you'd rather forget the other things, not these ones. Okay, as well as the halogenation ones. No. Okay, good. That is it. Goodbye for now.